Hello everyone. In previous module, we learned about basics of SQL Server transaction and properties of the transactions. In there, we discussed that among the four ACID properties of a transaction, isolation is the one that can be modified in SQL Server. In this module, we will delve deeper into the isolation property to understand its significance and how it can be adjusted to optimize transaction performance. When multiple transactions run simultaneously, they can interfere with each other in undesirable ways. Therefore, we need some sort of isolation or boundary between them to prevent those negative effects. Why do we need different isolation levels? There are three undesirable scenarios that can happen when multiple transactions work simultaneously. They are dirty reads, non-repeatable reads, and phantom reads. Let us first look at dirty reads. Let's consider we have two transactions, transaction A and transaction B. Transaction A is transferring money between two accounts, and transaction B is creating a report for manager on those same accounts. They both run same time. First transaction, transaction A, deduct 100 from account X, which made account X balance 1900. Same time, transaction B started reading account X balance, and because there is no isolation whatsoever, it has read the balance as 1900. For some reason, if transaction A fails and roll back, which means undoing already done steps, then account X balance become 2000 again. Now transaction B has wrong balance on account X. This is called dirty reads. It is dirty because transaction A never committed its changes before it was read by transaction B. This will give manager wrong information. If there were isolation between transactions, transaction B, the report, will have to wait till transaction A completes and then read data. But that means manager will need to wait a bit longer to get his report prepared. So there is a trade-off between correct results and performance. This is why we have several defined levels for isolation. So we can decide which performance level and correctness we need. Now let's take a look at non-repeatable reads. Non-repeatable read scenario is where you find transaction was not able to read the data it once read within the transaction. For example, transaction A reads some data. Transaction B then updates or deletes that specific data and commits its changes. If transaction A reads the same data again, it gets different value because values are updated, or it finds the data missing because particular row is deleted. If we take our banking example, a transaction A reads balance of a person and do some calculation to make some decision, for example, to see eligibility for bonus interest. Transaction A will make its decision based on the values it read. If it decides this person is eligible to bonus interest, then it will reread the balance to add that interest amount. But before transaction A rereads, transaction B deduct the balance of the same person and commit or save to the database. New balance could be not eligible for bonus. This is called non-repeatable read because transaction A couldn't reread the value it read earlier and get the same results for bonus calculation. Phantom reads. Phantom read is where transaction A reads a set of rows based on some condition, i.e. a where clause, and then transaction B insert a new row that meets the same condition and it commits to the database. If transaction A runs the same query again, it sees this new phantom row that was inserted by transaction B, but that wasn't there before. In our banking example, transaction A reads account with higher values. For example, let's say accounts higher than 10,000 for a report. Then transaction B updates an account which was not in transaction A's list and increase the account balance to over 10,000. In this example, its account Z balance increases above the 10,000. Now this account also matches the condition for transaction A. If transaction A rereads accounts again with same condition, for let us say for a section of a report, it finds a new account which was not there before. This will be confusing for report preparation. Isolation levels are SQL Server's way of letting you decide which of these phenomena you will willing to tolerate in exchange for better performance and concurrency. Stricter levels prevent more phenomena but can cause more blocking because transactions waiting for each other. So it is a trade-off between concurrency and data integrity.